All right. Hello, everybody. I'm Pierre-Yves from F5, and I will go through F5 journey of deploying a backbone in APAC. What we actually failed, what we've changed, and what we've learned. So, looking at, I'll just do a quick slide about who is F5. I promise it won't be anything, no sales pitch, no commercial stuff. It's just about I need to clarify why F5 needed to have a backbone in the first place. Then I go through the backbone history, what led us to have the need to deploy something in APAC, then the actual APAC deployment. So APAC stands for Asia Pacific, just for people who may not know the reference. So it's all about Asia Pacific backbone deployment. And then our backbone today, and also I'll add our experience, what we learned, etc. Going to the next slide, please, and the other one. Thank you. So you may know F5 as a hardware appliance company. You may have seen these kind of black boxes with a red bubble on top of it in data centers, in racks. So we are seen as an F5, as an appliance hardware company. It was true a few years back, but it's no longer the case because, next slide, please, F5 has made several acquisitions over the course of the few years back, and they wanted to build a big service portfolio. And these services, I won't detail them, it's not a sales pitch, but these services needs a network to be delivered. So this is why we actually needed a backbone. So next slide, please. A little bit about backbone history. So a few years back, a French startup, a few guys decided to build a network, a backbone, to change the way we do DDoS mitigation. Next slide, please. And we started, so as it was a French startup, when you want to build a network in France, you just have at least to be in two pubs in Paris, which are Equinix PA2 and Telehouse 2. So we built these pubs, and we expanded a little bit to the main Europe location and started to connect to the US. And after that, next slide, please. Yeah, all right. So Arcturus Networks merged with another startup, a US startup called Volterra, and their focus were primarily in the US, so we built network in the US for them, like for the whole company. And at this point, we needed to connect the APAC region because we started to have customers there. And next slide, please. So the other one, yeah. So deploying a backbone in APAC has several challenges. APAC is far away from everything. And we can connect to it rather either from Europe or from the US. We decided to connect from the US. It was better for us in terms of resilience and in terms of costs. Sometimes cheaper to go from the US than from Europe. In terms of distance and latencies, to put that in perspective with Europe, our two most distant pubs in Europe are Stockholm and Lisbon, and you have 50 milliseconds between these pubs. 50 milliseconds is approximately what you have between Hong Kong and Tokyo. And our closest pub in the APAC region is Hong Kong and Singapore, and it's 30 milliseconds. So everything takes huge proportions in terms of distances. So, as I said, where do we start? We decided to start from the US. Next slide, please. Yeah. So we started, we didn't really know actually how to connect there. I've had an experience in the past having pubs in this region, but these were islands. They were not connected together. So as we didn't know the market for backbone circuits, we wanted a simple solution. So we went for layer 2 circuits, 2 gig layer 2 circuits over NPLS backbone. We thought ourselves, all right, this will be easy. and we thought that there will be a lot of resilience. If one submarine cable cuts, will be rerouted to another one. Actually, we were wrong. It was unreliable. It was down all the time, a lot of packet loss. We worked for months with the provider to try to solve this solution, these issues, but we were not able to. So after a few months, we looked at other solutions and we asked ourselves how difficult it is to do it ourselves. So we did layered circuits. We went with 10 gig wavelengths. We were like 3 different cable paths per pop, and with submarine cable diversity. And we thought, oh, this will be good, etc. And actually, no. We also studied the backhaul, the terrestrial backhaul diversity. So from all the CLS, so the cable landing stations where the cable are powered, the subsea cable arrived on the land. We studied everything to make sure that the terrestrial backhaul was diverse as well, but it's not enough. Cuts happen frequently and can take several weeks until repaired. And maintenances, even though are not always impactful, happen more frequently than on terrestrial cable in our experience. So we have to take that into consideration. So if there is a maintenance, there's a risk that it will fail. So why so many issues? First off, next slide, these. Again, next slide, you see the red dots, so the anchors. And if you look at the next slide as well, this is a Singapore harbor. You have loads and loads of boats. So a lot of cuts happens here, not only here, but it's a big passage. Next slide, please. Also the Ring of Fire. So it's a chain of volcanoes. So we have a lot of geological movements, and that breaks cable frequently. Not frequently, but it happens, and it takes weeks to repair. So we decided to add a new pop, more diversity. We wanted to go with, little more cable, but still not enough. We had more capacity, so that was great, but it didn't help us solving the resilience issue. So next slide, we went back to the drawing board. Next slide, please. So we actually heavily studied all the submarine cable that were commercially available. When you see that slide here, you see a lot of submarine cables, but a lot of them you can't buy capacity on, either because they are full or they are not on the market for selling. So we took all these cables and next slide, please. What we've done is we've mapped out all the cable landing stations on each countries and try to map all the cables on top of that. So if you look at the next slide, we see that every cable we were able to get a pricing on that was available commercially. We tried to study, all right, if we want a full diversity, we want to have different cables, because looking at that, you may have a different submarine cable, but if they land in the same CLS and the CLS burns or there is a problem here, there, you lose both of your submarine cable at the same time. So on the land, you need to check that as well. Next slide, please. We also mapped all these subsea cable with a KNZ provided by the providers to make sure that we were able to see the diversity up to the subsea cable. And when it lands, so we looked at the beach manhole. So BMH stands for beach manhole. It's where the actual subsea cable meets the terrestrial fiber. And from there, it goes to the CLS, who actually powers all the cables. So we looked at the diversity, even though, let's say you have 2 different CLS, but the 2 submarine cables go inside on land on the same beach manhole, and there is a landslide there, you might have an issue as well. Next slide, please. We also studied all the terrestrial backhaul up to our data centers. So Hong Kong was difficult due to the geographical position of our data centers. It was very difficult to find diverse paths there. But what was great is that our data center provider as well as our wavelength provider, were able to share a lot of detailed information about the KMZ to make sure that even the campus cross-connect between the DCs, where we could have connection for these waves, we had this information to make sure that when we order a cross-connect, we want to make sure that we take a path that doesn't cross another path we want to avoid. Next slide, please. So after that, we went to, after studying everything, we upgrade everything. So in the meantime, we were acquired. So the Volterra merger was acquired by F5, and F5, with their ambition to be a SaaS provider, wanted to have to do better in that region. So we upgraded everything. We went from 120 gig of capacity to approximately 1 terabit of capacity there. We actually used more submarine cable systems, so more diversity. At least 4 different paths per POPs. And we actually wanted, on top of that, to add a layer 2 provider as a last resort backup. So should the 4 path or even 5 path in some places go down at the same time, we wanted to avoid a single POP being taken offline, which happened previously with the 10 gig waves with 3 wavelengths. All 3 went down at the same time because one submarine cable, when it gets down, it takes 6-8 weeks or even more than that to be repaired. So you have a high probability to have another cable system that fails or goes into maintenance. So if you have 2 out of 3 wavelengths that are down at the same time, so it means that you can't do an upgrade on the router. You can't do a maintenance on your side on the router that you have left with the last link. So we wanted to be sure that this should not happen. And at the time, we were like, we'll never use these layer 2 circuits because all POPs have at least 4 physical diverse paths. So this is overkill. We won't use them. But next slide, please. Here you can see the last 6 months of our wavelength in APAC, the availability. Each line here is a time series of green, the circuit's up, red, it's down. Gray, it just means it was not installed yet. So we have 3 circuits that are less than 6 months old. So exactly like before, outages last forever. We had some issues there, but this didn't lead to any POP availability. But we had a close call. If you look at the next slide, 4 out of 5 circuits down were related to the same POP. So we have 2 Singapore to Hong Kong POP on the same path. We have a Hong Kong to Singapore, which stayed up, but we have a Osaka to Hong Kong, and the Tokyo to Hong Kong wasn't delivered yet, so it was not yet ready. And actually, the delivery was delayed because there was a maintenance on that cable. So we had 4 different paths and 3 paths, and that were responsible for 4 different waves went down. Next slide, please. So, and on top of that, the last available circuit, you see the one between Hong Kong and Singapore, was actually having CRC errors on it. So it was not reliable enough for our operation. Thankfully, we were able to use our layer 2 backup. So we spin up layer 2 circuits between Hong Kong and Tokyo, and Hong Kong and Singapore to Tokyo. We had to do some little adjustments. By adjustment, I mean that we removed all Anycast BGP announcement on that POP to make sure that POP was dedicated for our local customers only. And everything that was Anycasted on Hong Kong was actually delivered by the other POP in the region, so Osaka, Tokyo, and Singapore. Next slide, please. So this is what we are running today. It's been 6 months. We are happy with that. And how does this compare to other regions? Next slide, please. So you can see I've put the APAC last 6 months circuit availability here. And if you, next slide, compare that to Trans-Pacific, you see that, so we have 5 circuit Trans-Pacific, 3 circuit transatlantic, and then North America. We have a few circuits as well. If you click, yeah, and last one, okay, Europe. What can we see here? So if you click once more, please. So no surprise, submarine cables means longer outages. And we can see a pattern where everything in the Pacific or Asia-Pac usually all the outages take longer than transatlantic in general. And if you look at North America and Europe, even though you have a lot of maintenances, either it's from the provider or on our side or stuff that we've done, you don't have outages that last as long as submarine issues. Obviously, it's terrestrial, so it's easier to fix, and it's way cheaper. Why is that? Let's say that you have a few boats in the Pacific Ocean that are responsible for the maintenance on all the submarine cables. So if you have one cable that is down, you may take, the boat may take longer to get there because of the weather condition, etc., the time to get there. And if the same boat is responsible for multiple cables and another cable is down, this same boat has to fix the first cable, go back to shore, load a new team, and go back to the second outage. And we have other issues as well as, if you go to the next slide. Okay, last minute bonus. I did this slide a few minutes before that presentation. So last week we had 2 cable cuts, 2 issues on Hong Kong as well. So the Singapore to Hong Kong cable, we are still waiting for authorization for repair. Actually, when you are not in international waters, you are relying on regulation for each countries where these waters belong to, and we are having issues with the first one. So it's been down for more than 4-5 months, something like that. And last week we just had a submarine cut on our Osaka to Hong Kong, and we had a maintenance on our Tokyo to Hong Kong. So we still have 4 out of 5 circuits to Hong Kong that are down. So we once again activated our layer 2 backup just in case our last circuit goes down too. Next slide, please. So what does our backbone looks like today? So during this APAC deployment, we continue to add new cities and new stuff. And as you can see in green, so Montreal, I won't speak about this right now because it's terrestrial, it's in North America, it's easy to connect. But we have now to work on Tel Aviv and Dubai and Lima. So all this work that we've done for APAC, we'll have to redo it all again for Middle East and Latin America. So we had a good experience on that, and that's work again to be done. So it's hard work, but I think helps. And if you go to the next slide, please. Next one. All right, so our experience deploying everything. This is expensive. The Asia-Pacific region accounts for approximately 50% of all our backbone costs, if you take into account transit, peering, and backbone circuits. Submarine cable outages last for months, and this increases the probability of having multiple cable cut during the same time window, which happened. As you can see, we have 4 circuit down currently as I'm speaking right now in the Asia-Pac region. And we also have 2 Trans-Pacific circuit down as well. So connecting, right now our backbone has 6 circuit down towards the region. In order to be close to 100% availability, you need to have more than 4 paths. So at least 4 paths to get close to 100% availability, but things can still go sideways compared to Europe, where as terrestrial gets repaired faster, you can get away with less diversity, but it's incredibly important over there. And we, as I said earlier, we initially thought that the layer 2 backup was overkill with the diversity we had, but it turned out we used it multiple times. It took a long time to do all these studies, all the KMZ, the landing station, beach manhole, all the backhaul. But I think it was worth it. If we have to invest that amount of effort and money to build a backbone, that was something that was important for us. And it was nice to see that all our circuit providers and our data center providers were always available to help, at least for the circuit providers to be able to do some terrestrial backhaul modification to meet our diversity requirements. So it was not an easy task. And sometimes when you are happy, let's say in Hong Kong, with your diversity in terms of landing station, in terms of terrestrial backhaul, so you select one path, but actually it leads to issues on the other side, let's say in Singapore or in Tokyo. The fact that you have the diversity you want in Hong Kong may mean that you don't have the diversity you want on the other end. Something that I didn't work on, but my colleagues find it sometimes extremely difficult to ship hardware and dealing with customs. Importing and exporting network gears were very difficult. And I think that's all for me. If you go to the next slide, it's time for questions. And thank you very much.
We appear to have some remote questions. So a question from Dave at Glide. Do you get any sort of compensation from the submarine cable operators for these extended outages?
That's a good question. I wanted to mention that. So when you discuss with these providers, they say, oh, we have 5 nines availability, but you have a small asterisk, which is like, all right, even the force majeure doesn't count. So a submarine outage doesn't count against their SLA. So usually they are not bound to give you any sort of credit, even though most of the time they want to keep a good relationship with you, and they can work out things to make sure that you have compensation of some sort for that. So, but usually submarine failure maintenances doesn't count against the SLA.
Mm-hmm. There's a follow-on question, which is, did you find that any of your redundant links ended up sharing fate or having the shared fate that you didn't expect? So one went down and something else went down, or move of transport, etc.
So we did an extensive work looking at all the KMZ, and all of them were fine. So we didn't have unexpected cut. So that was a good thing. That happened to us in Lisbon, but that was in Portugal, because 2 circuits arrived on the same physical equipment. Everything was diverse, but that didn't happen to us in the APAC region. So yeah, but that probably is thanks to the work we've done by studying everything. The KMZ study took a long time, and the provider were giving us the real data, the real information. So we didn't have any unexpected surprises.
I think that's it. Thank you.
All right. Thank you very much.
I'd say thank you very much indeed, Pierre-Yves. That was an excellent talk. I've got to be honest, that one was quite so information dense. I should probably have to go through those slides separately because that was a lot of stuff.